Hey guys, how you doing? This is Coach Scott with Purple Wave Chemistry, and we're going to talk about one of the really neatest formulas in chemistry. It's the ideal gas equation. It's very, very powerful in that it allows us, if we know pressure and volume and temperature, we can find moles, or vice versa. If we got three out of those four variables, we can find the other one, right? And this allows us to find moles to where we can do gas stoichiometry, which is sort of cool, right? Uh, I know y'all love stoichiometry. Anyway, this is a pretty fun one. Let's talk about this one. So I got a 250 milliliter flask of hydrogen gas that we collected at 763 millimeters of mercury and 35 degrees C by displacement of water from the flask. Of course, we cannot use that pressure, and that temperature is totally not good because it's not in Kelvin. All right. And it also tells us that the vapor pressure of water at 35 degrees C is 42.2 millimeters of mercury. So they're asking how many moles of hydrogen gas are in the flask, just for fun, right? So I've got a volume. Get my pen going there. I got a volume of, let's go ahead and make it liters, 0.250 liters, all right, of hydrogen. And I collected it at 760, I'm going to call that P total, of 763 millimeters of mercury. So right there, that's going to tell me what my R value is going to be. And if you did what I asked you to do, write this down at the top of your sheet. If we were in atmospheres, we'd use this for the gas content. We don't have atmospheres. We're going to use this one, 62.4 millimeters of mercury, because that's what we're dealing with now. And I don't want to convert to atmospheres. It's a hassle. Don't fool with it. All right? So that's my gas total. So my pressure of hot water at that temperature, let's look and see, is what? 42.2 millimeters. Right. So my pressure of my hydrogen gas, all right, is the sum, the pressure of the total pressure is the sum of both of these. Well, we don't know hydrogen. We're going to calculate it. So if I subtract the water from the total, that should give me the pressure of the hydrogen gas. And I get 720.8 millimeters of mercury for hydrogen. Okay, so that means I got volume, I got my pressure of hydrogen. Let's see, I've got my R, I got my temperature, but that will not do, right? So we're going to go ahead and convert that temperature. We're going to go 35 plus 273, because, that's how we convert to Kelvin. And that'll come up to 308. 35 plus 273. So now that means I've got pressure, I've got volume, I've got temperature. This is going to give me enough to find the number of moles. So we're going to manipulate PV equal nRT to find the number of moles. So I'm going to divide through by RT. I do this on that side, regular algebra. So that means PV divided by RT will give me the number of moles. So pressure is what? 720.8. Volume is 0.250. My R is 62.4. And I can go to the top if I wanted to check that. And my temperature is 308. And that'll give me what? 720.8 times 0.25 divided by 18.4 divided by 308, and I get 0.00937 mole. And I can record it like this: 0.00938, 938, or I could do it in what's it called, scientific notation, times 10 to the minus 3 moles. Either one doesn't matter to me. Let's look at one where we're doing some, ooh, this is a good one, where we're doing some stoichiometry. So zinc metal reacts vigorously with chlorine gas to form zinc chloride. Okay, let's write that reaction just for fun. So zinc metal, Zn, plus Cl2, chlorine gas, forms what? Zinc chloride. So Zn is plus 2. Yep. Cl is minus 1, so that's going to need 2 of those. Alright, so now I'm done. Zn, Cl2. It looks like that's balanced, so I've got a 1 to 1 to 1 ratio. Okay, cool. So what volume of chlorine gas at 25 degrees C, let's just go ahead and convert it, 25 plus 273 equal to 298 K, and pressure of 1 atmosphere is required to completely react with 1.13 grams of zinc. Okay, so that means I've got to find the number of moles of zinc. Zinc, 1 mole. 1 mole of zinc is 65.38. Let's see how many moles we got. 1.13 about 65.38. So I got 0.0173. Let's write that down. Oh, 0.0173 moles of zinc. Alright, so let's do a BCA. So I got that many zincs beginning of the reaction. Alright, for every 1 mole of zinc, I'm going to need 1 mole of chlorine gas. If I don't have 1 mole, I've got 0.0173, so of course I'm going to need 0.173 moles there. Subtract that, we'll end up with 0, 0, and start with 0 on that. I'll make that, and that's what's going to be at the very end, plus, minus, minus. So that tells me how many moles of chlorine gas I've got. 0.173 mole CO2. Okay. And it's asking for a volume. Okay, cool. Well, let's use what we know. So PV equal nRT, solve for V. So nRT over P equals volume. So my N is 0.0173 times R. We're in atmosphere, so I got to use 0.0821. Let's see why I know that. I went up to the very top. I look, just to double check, and there it is. So good. That's my R, my budge factor. What's my temperature? 298 K. Of course, I have 1 atmosphere of pressure. I love it. All right. 0.0173 times 0.0821 times 298 I get 0.423 liters. 0.423 liters or 423 milliliters. I'd leave it in liters. It didn't ask for anything different. Go with it. Alright guys. So if you want me to do any more of these, let me know and I'll be glad to. We've done some more of these in class. But if you'll email me, text me, something along that line, I'll be glad to do some of these tomorrow night for you guys. And again, as long as you get this in by Wednesday, I don't care if you're B-Day, you're good to go. So anyway, this is Coach Scott saying, hullabaloo, connect, and let's go Purple Wave. And that's it for Purple Wave Chemistry tonight. Have a good one.